Thanks very much, Nolene, for organizing this, and for the Geological Society of South Africa for hosting it. It's a great pleasure, and I have such fond memories of South Africa and the people there. So Nolene asked me to talk about what my day is like, or what a research scientist does. Apologies if there's going to be a lot of pictures of me, because I guess it's a day in my life. So here, let's get on to it. All right, so a brief bio. I did first 2 degrees in geology in the UK, one at Aberystwyth and the other at Imperial College. And they were both hard rock degrees, lots of mineral petrology, lots of igneous and metamorphic petrology. And then I came out to Mmabatho, met Nolene, and the job that I was given there was as a hydrogeologist. And so I didn't know much about hydrogeology at all. So I took a master's degree in research on the hydrogeology of the Pilanesberg at Wits, and that was great fun, lots of field work that I was doing anyway. And then I went on to UCT and got a PhD in high fluoride groundwater, basically geochemistry. And this was the day, one of my proudest days of getting a degree at UCT. So after that, I kind of wanted to leave academia as much as possible, and I went on to do a whole series of other jobs. I was a cement journalist, believe it or not, for 3 years. I went around the world looking at cement factories. I worked as an aid worker, where I met my wife in Angola, and we got married. She's from the US, which explains the reason why I'm here. And then I went back to the UK as a hydrogeologist, environmental manager, and eventually came over to the US and became a professor and consultant and so on. And finally, I'm working now as a limnologist, a research scientist. And so coming from a background of geology, hard rock geology, I'd have never known what any of this was, but it's the study of freshwater bodies of water. It was first established in Switzerland by this old gray guy here. And he looked underneath the surface of lakes for the first time, and in a scientific way, and looked at biology, chemistry, circulation and sedimentation, and found it to be a very fascinating and dynamic situation. So now the science has bumped along for a couple of centuries really, but it's received more interest because of harmful algae blooms. And I know that there are problems with this in South Africa as well. Hartebeestpoort Dam has had problems. And so HABs have made limnology ever more relevant. And the interesting thing is that so many people are now looking at this problem, from scientists to engineers to social scientists. And because of that, it's a fascinating multidisciplinary nexus, if you like. And this is just a picture of a boat out in one of our lakes, and you can see that it's surrounded by harmful algae blooms. And the area that I'm working on in New York State is called the Finger Lakes region. We've got these series of elongated lakes. Some of them are very deep, and they're glacial in origin. And you can see each of these dots is the point of a public report of a harmful algae bloom. So they are widespread at times. So some of the tools that we use as a limnologist, this is from a recent field trip out to one of our more beautiful lakes, Green Lake. It's a glacial plunge pool lake. You can see that I'm dangling something over there. On the end of that is a black and white 8-inch diameter disc called a Secchi disc. We use that very primitive tool to measure lake transparency, but it is kind of standardized all around the world and has been for 200 years. And because of that, despite its simplicity, it's very useful. We also use a plankton net to pull up zooplankton. From a 20 micron net, you can capture some really interesting bugs, and they can tell you about the health of the water. And we'll use a multi-probe, which will measure things like temperature, conductivity, dissolved oxygen, chlorophyll, and so on. And we can also obtain samples from discrete areas in a lake by using these special devices called camera bottles or Van Dorn bottles, and they will trap a sample from a particular level in the lake. So I must say that it's a lot of fun doing limnology. We also do underwater video because we've had a great influx of these aquatic invasive species, in this case, zebra mussels and quagga mussels. And for this, we just came up with a contraption with lights and a GoPro on it, lower it into the water and let it nestle down to the bottom. And from this, we can do quantitative assessments of density and so on. Now, funnily enough, although as a limnologist, I'm interested in lakes, obviously lakes are fed by rivers. So we have to measure chemistry in rivers, and we're also interested in the flow in rivers so that we can work out a load. And so a couple of the pictures here, this is using a game camera to check out how high the river is. This is also paired up with a pressure transducer, taking water samples, and a couple of my students measuring discharge. And we're also doing gradient studies in one of our labs as well. One of the things that I introduced, that this might not happen a lot in South Africa, I can imagine, and that's winter limnology. So this picture is us out on a frozen lake with snow on the top of it. I know you're just about to go into your summer, but hopefully your winter wasn't quite like this. So a lot of the projects around the world only consider the lake conditions in the summer and possibly in a little bit in the spring and in the autumn. So for this one, we went out specifically to measure what was happening during the winter. We have to drill through the ice. The ice is always at least 4 inches thick, otherwise we don't go out. We use special plankton nets, which are a little bit smaller in the mouth so that we can fit them through these smaller holes in the ice. And you wouldn't believe how active the plankton is even under the ice and in those cold temperatures. And possibly the reason is the stability of the water column. We still took video through the ice, and to do that, we came up with a contraption here that is just 6 inches in diameter and fits through the ice and then is spring loaded to deploy the lights. And then finally, even if it's not cold enough for the lakes to freeze, we're still going to go out in the snow and get some of our readings. So I must say it looks kind of tough, but it was a lot of fun. Now, something that I struggled with is lake ecology. Being a geologist, just a simple geologist, there is so much diversity in these lakes. And I think that that's an untapped area, a great area for research for us to work out whether harmful algae blooms are not just dependent on phosphorus and micronutrients, but also on how they are grazed and so on. So we've just got a couple of Asterianella here. This is Microcystis, that's the harmful algae bloom, a dominant species in New York State. And we've got some lovely pictures of Daphnia and another large zooplankton here. And with our underwater video, we also get some great pictures of perch and other panfish, as they call them here. Now, one of the things that I've enjoyed most of all is moving the limnology in New York State, at least, into the satellite era. And we are using satellites as a research tool to see if we can look at harmful algae blooms. There's lots of interferences in satellites. It's just my wife there. And we can see, because of the clarity of the water, we can see the lake bottom. We can see some weeds here, sediment plumes, and some of the sediment in some of the lakes. We can also see some contrails and an aeroplane coming past here. We have to take into account atmospheric interference. Obviously, this is the moon, no atmosphere, bad place to have a party. That's a joke, by the way. But here's one of our lakes. Trees are green here, but they're blue up at the end. And so we have to take atmospheric interference into account. And because the lakes are so clear, we can use something called ICESat-2, which is it's actually meant for measuring Greenland and Antarctic ice caps, but we've repurposed it to look at not just the surface of the lake, but the lasers from this satellite will go down to the bottom of the lake in some cases. And at this point, it's seeing 20 meters below the surface. And that means that when we're using satellites to work out chlorophyll concentrations, we have to take into account the bathymetry, the shape of the lake bottom, because otherwise we might not be looking at water, we might be looking rather at the lake bottom. And I just love this satellite because it's freaking laser beams from space. What could be more cool than that? So using this technique, we've got 18,000 water bodies in New York State using the latest European Space Agency satellite, Sentinel 2, that's been around since 2016. Even the smallest lakes at 3.5 acres that we can really distinguish what's going on, we still get over half of the lakes in New York State can be resolved. So that's an exciting capability. All right, so that's giving you an idea really of the life of a limnologist. I would just say in summary that geology and earth science is a great basis for any environmental science career. As you can see, my career path has bounced around quite a bit, but I've settled into this, what I find is a really interesting subject. But all of those different jobs that I got did give me some experience, valuable experience. So I'll just leave you with this. The world is full of opportunities, even or especially when life takes an unexpected direction. So this happened recently, not to me, but you know, I guess the person that did this learned from experience, and it's a great opportunity to either stay off the booze, get a driving course, and get a new car as well. So I'm going to say thank you very much. This is my crew, Amy and Tony, and here's some acknowledgements and references if you're interested. So with that, I'm going to hand it over.